Hello everyone, thank you very much for joining me again for lesson 11 from the Spring Security stream, and we are already discussing about OAuth 2 and how to build such a system with Spring Security. Well, one of you let me know earlier that I actually skipped to discuss the matchers methods and authorization rules, and I checked out and that's true, but because of the fact that I have already scheduled the OAuth 2 part, I will first take the OAuth 2 part and I will leave the matchers method afterwards. Anyway, I just wanted to let you know that I won't skip anything that's important, so thank you very much for letting me know. And after we discuss everything about OAuth 2, I promise you I will get into that as well, and nothing will be skipped. Now, if you are watching the event live, don't forget that you have a live chat there, so you can ask me the questions during the lesson in the live chat. And if you are watching the event recorded, you can still ask questions in the comment section, or you can find me on LinkedIn or Twitter and ask me questions there. So with that being said, let's see what's this OAuth 2 all about. And today we're actually going to start with the first component of the OAuth 2 system and how to implement it with Spring Security, and that's the authorization server. Before going to further and securing a backend application, we first need, you'll see today why, an authorization server. So I have prepared first of all a diagram, and I want to discuss this diagram before going into my IntelliJ and starting a new project together with you, of course. So this is what you see here is what I prepared for the diagram, and that what I consider actually very important for you to understand before going into writing code, of course. So you need to understand what you actually write and what you actually implement. And let's see how do we rearrange these actors into what is a system. The architecture, the simplest way of describing the architecture of a system over OAuth 2 and what's OAuth 2 all about, and then go straight to the IntelliJ and implement an authorization server. So we have a user. This is our user using an application, and this is called the client. So when we refer to the user, we refer to the actual user. I will just put it here, the user, and then we have the client. And I already have a question. I haven't still watched your previous videos. It is still okay to watch today. Yes, you can watch the videos anytime, so they are there recorded on this channel, so you can watch them. It's free. You can ask questions in the comment section. So and if you want to watch this video today, yes, it's okay. It's just for you. If you want to watch it, it's nothing can stop you. So yeah. Of course, it will be important that you know all the previous lessons in the end, but nothing will happen if you rewatch it later as well. So I do recommend you watch the videos, and if you feel that you need to rewatch them, do that as many times as you need. So thank you for your question again. And this is actually the user and the client. The client can be an Angular application, a React application in a browser, can be a mobile application. So I have a browser here, but it can actually be only a mobile application running on your mobile phone or on your tablet. So any kind of application acting as a client, and that's directly used by the user, this is what we call the client in the OAuth 2 system. And then we actually have two servers and two server-side components, let's call them, two backend components when we discuss about OAuth 2. So I have actually copy-pasted here in the diagram, and I have these two backend components, as you can see, represented as two servers in my case. One of them is actually called the authorization server. So this is basically my authorization server. I'm not sure how do I increment it, but you understand the idea. And this is the resource server, so-called the resource server. Okay. And these are basically the components. Now, what OAuth 2 is all about is how to allow the client act and do something for you. This is you, the user. So you want to, for example, see your statistics in your application. Whatever these statistics are, there are some information related to you and you need to see them. And for that, you use the client application. So in order to take these statistics, the client application needs to call the resource server, which is actually the backend that we are protecting. So when we say a resource server, it's just a more fancy way to say the backend of the client. So this is the front end and this is the backend. When we actually had only a normal system, we only referred to a front end, which was the client, and the backend, which was the backend implementation, the backend application called by the client, say by the means of some REST endpoints, by the means of some REST web services. So in the end, all our system is still formed by the client and the backend is just named, in the case of an OAuth 2 system, the resource server. Then where does this component appear in this case, and what is this new component that appeared in case of the OAuth 2 system? Is called the authorization server, and it's basically managing the users. So we have no longer information about the users in the resource server. We have information though in the authorization server. So this is why I have a database for both of them, knowing that in this case this database might be the one used by the business implementation of the resource server, so the data related to your application, and we still have some data at the authorization server side, and these are the users. So the component knowing who are the users is called the authorization server, and then in order to be able to call any functionality from the resource server, the client has to first get a token from this authorization server, and that token will allow the client call some of the endpoints of the resource server on behalf of the user. So the steps basically are like this. One, the user requests something, and that is, it actually uses the client to do something with the application. And then the second thing that happens is that the client, knowing it will have to call something on the resource server, goes first to the authorization server and asks for a token. It says, look, user X asked me to do something and call some resource on the resource server. Do you allow me to do that? Can you allow me call that resource? And assuming everything is fine and the credentials are correct and everything, you will see that the user still has to provide some credentials. Then the authorization server will tell the client, yes, it's fine, you can actually go and call the resource server, and you will provide this token to the resource server proving that I have authorized you. So a token goes back from the authorization server to the client. This token is only something that, like a password, like any kind of proof, the client could use to present to the resource server in order to be authenticated, in order to be authorized, in fact, to call the resource it needs. So what does the client do first? It simply sends the token through the request to the resource server, and it says, look, I need that data, I need to provide it to the client, or I need to do that change, or whatever the endpoint is, I need to call some action, and in order to prove that I've been authenticated, this is my token. And then the resource server somehow looks at the token and sees that's fine, and it's indeed the token that has been provided by the authorization server, and allows the client to do that action on behalf of the user. So this is mainly all about, but we will have to ask plenty of questions in this case. So for example, one of the questions is how do the credentials get from the users to the authorization server? Do they get through the client, or are they actually sent directly? And do we always need credentials? So these are some of the questions related to credentials. You will find out how this happens starting today in this lesson. The second question would be, then if the resource server receives this token, how does actually the resource server know that this token is a valid one? Maybe it's simply only a token that was invented by the client. So how does the resource server know that this token really was issued by the authorization server, and it's not somehow a fake token, or something that was simply created by the client and not provided by the authorization server? So we still have a lot of things to discuss, but mainly the picture you should have in mind before going further is that OAuth 2 has as actors a user, a client, an authorization server and a resource server, and then all about OAuth 2 is how to get a token to be authenticated. And getting a token to be authenticated, if you want to think in terms of an analogy, if you want to think in terms of a real-life analogy, is precisely as you are going to a building and you are going to the reception of the building and you present your ID to get an access card. So imagine yourself going into a building, like an office building, you have your ID with you, you present your ID at the reception, and somebody from the reception validates your ID is authentic and gives you an access card that you can use to access some of the doors. This is precisely what happens in OAuth 2. So the client uses the credentials, like I was using my ID at the reception. The reception is the authorization server, and the authorization server gives me back the token, which is what in my analogy the access card was. I get the access card, and then with the access card I can access some of the doors, not necessarily all of them. Like the client using the token can access some of the endpoints of the resource server. So this is basically it. This is how it's working. Again, we have to discuss a lot of details. This is why OAuth 2 is not simple. It's easy but not simple, and this is why we will discuss it in multiple lessons together with the implementation that you will need to know. And you will see a lot of variations from OAuth 2. For example, you can even have this responsibility, which is called the authorization server. Usually is developed in a different component of the system itself, so it's a different application. But you can actually have both these responsibilities into the same application. That's not very usual, but you can do that. In the end, in terms of theory, in terms of the philosophy, these four that you see here, these are only some responsibilities: the user, the client, and the two backend responsibilities. So you will see situations, I've seen plenty of situations actually, even if it's not that usual, where the same, for small systems, the same responsibilities were implemented in the same application and not in different applications, but we will get to that as well. So with this introduction being said, I hope now that you know which are at least the actors, which are the main responsibilities, and when I will say client, authorization server, resource server, or user, you will know to which of these I refer, and then you basically know at least a little bit of each of the responsibility of each of them. So with that being said, let's go further and today implement the authorization server, because you see we couldn't have started with the resource server. The resource server is only a normal application exposing some endpoints that needs to be protected, that needs to be secured. So we need first a way to obtain the token in order to prove otherwise that when we implement the resource server we validate this token. So we can't start with any of the others. By the way, in this stream we will only refer to Spring Security, so we'll only refer actually to the backend side that's implemented with Spring Security. We won't develop something like an Angular application or React or something, but we will use Postman to prove the entire flows that we discuss, and we will prove that everything we do on the backend works precisely as we intended them to do. So this is basically what you will learn from this Spring Security stream that you are now watching directly. Okay, that being said, again, let's go and implement the authorization server. The authorization server is quite at the moment is a very discussed subject because of the fact a new authorization server project was just started a week ago or a couple of weeks ago, and I have also I have also written a comment in the community section of this channel when that happened, and what you will see is that in the next year probably this new project being started from zero will at some point become mature. So what I will show you today is what something in a year from now on will probably become legacy. Well, some of them already call it legacy, but don't trust them, because at the moment this is still the only way we can use to build an authorization server with Spring Security. So until we have another possibility, this is still anything that we can use to develop the authorization server. So I will teach you how to do that, and most probably at the point where we will have a mature implementation of the new authorization project, that I don't think it will happen in less than a year from now on, I will show you of course how to implement that at a specific point. And in practice, you find two situations: one in which developers implement their custom authorization server, like I will teach you to do that with Spring Security in this stream, but they have also the situation in which they use a third-party tool like Keycloak, Okta, Cognito, if we discuss about AWS, and actually the clouds themselves offer usually their own service, all of them. So we have plenty of third-party solutions for the authorization server. But from my point of view, you need to understand both of them, because I myself have found situations for projects I have done consultancy for where the stakeholders didn't want to use a third-party tool, and then they actually wanted, for specific reasons only they knew, a custom implementation. So for that reason, you can't always say I will rely on Keycloak, because there are situations in which you can't rely on Keycloak because, well, somebody who requires your software doesn't want that. So that's why we are basically starting with this authorization server. And let's get to my IntelliJ. I still have the last project we've created. Of course, we need to create another one. So let's start it from zero. We create a new project, Spring Boot, and then I actually call it C11 because it's the lesson number 11, and using Java 14. What do we need to add here? So authorization server is still a web application, so I will have to add the Spring Web dependency, and of course I need to add Spring Security. And besides this, everything related to what we can use now to build an authorization server relies inside the OAuth 2, the Cloud OAuth 2 dependency. So I will have to add Cloud OAuth 2 as well. And I think basically if we don't want anything anything fancy to implement besides the authorization server, these three dependencies are just enough for us. Because the authorization server manages users, as you will see, most probably in a real world scenario you would like to store the users in a database. But I would like not to complicate the example now and allow you focus only on what's important, and that's Spring Security. And you already basically know, if you have watched the previous lessons, how to manage users in a database. So we don't need to actually redo that because you can find them in actually one of the first lessons on this of this stream that you can already find recorded on this same channel. So with this dependency, it should be just enough for us to implement our custom authorization server. So I have my my project here for lesson number 11. And I should wait probably a little bit for it to be indexed. Okay, I think it just finished. And in order to create my authorization server, I basically only need to do a couple of configuration classes. So let's create a package. And the first configuration class I will create, I will call it user management config. And this is what you actually know will manage my users of the authorization server. So wait, why do we need to manage the users? Very simple, because what we discussed on the previous diagram was that the authorization server basically, this is its responsibility. It only manages users and makes sure to issue tokens in specific ways. So this is why on the authorization server side, we need now to manage the users. All the user management moved to the authorization server. So this is why on the authorization server now, we'll have the user details service and the password encoder. And you probably remember these two very important components of the authorization server, the user details service, which we've discussed in basically the first lesson of this stream, I think, and the password encoder as well. These are the two main contracts dealing with the user credentials. The user details service gets the user details and the password encoder is used to verify the password. So that's what we also have to add to our context now here, user details service. And of course, we want to put it in the Spring context, which means we need to annotate the method with @bin. And because now I want to simplify a lot my example, I will simply use an in-memory user details manager for my implementation. But you know that you could have used, for example, the JDBC user details manager to directly connect through JDBC to a database. You can use an LDAP user details manager if you want to use an Active Directory or something like LDAP. You could implement even your own user details manager, and we have done that in one of the first lessons of this stream, and we have used JPA and Spring Data for that. So just to remind you, we've done that. If you still need to review them, of course they are there, the videos, and you can review them whenever you need. So let's create our in-memory here user details manager, and in this case, we'll rely on this in-memory implementation, which is enough for us to prove what we want to prove. That's the functionality of the authorization server. And of course, we need an user, at least an user. And I will create the user using the builder class, which you've learned to use for any kind of proof of concept or example. Let's call it John. And we need a password, and I will assign the 1, 2, 3, 4, 5, and then you know you need at least an authority, and we don't really care about authorities now because we don't we'll not discuss anything about authorization, but we need an authority at least, and then we build it. And of course, having the user, then UDS create user, and you can add it to the manager, and then by returning the manager you've made it been in the context, and now Spring Security has it, and guess what, it will be able to use it to retrieve the user details, so we can work now with this user. And of course, you know that we can't actually use the user details service defined by us if we don't provide also a password encoder. And again, to keep things simple, we'll still use the no-op password encoder, which I remind you, this password encoder is smart as deprecated because you should never use it in a real world scenario. Is that password encoder that doesn't encode your password. So in order to not encode our passwords and be able to see them in plain text in our example to make things easier, I will use the no-op password encoder. So that being said, that's the user management part of the authorization server. So now we have users. What else do we need? If we go back to the diagram, you will see that also the authorization server needs not only to know the users it authenticates, but it also needs to know the clients it allows to use its functionality and to which it will issue tokens. The authorization server doesn't issue token to any application. It needs to know the application it's allowed to issue tokens for. It can have multiple applications, but authorization server needs to know them. It can't simply just issue tokens to everybody. So for that, we will actually have to define separate credentials that represent the client. We have credentials representing the users, but we need some separate credentials representing the clients for which the authorization server can issue tokens. So that being said, I'm going back and I will create a second configuration class, and I will call this configuration class the authorization server config, and I will mark it as well with configuration because it's a configuration class. And then first of all, in this authorization server config, I will also make sure I do enable the authorization server functionality, which is done by adding the enable authorization server annotation above the class. So now I have enabled and I have made this application an authorization server. I have given it the responsibility of an authorization server, and I need to specify who are the clients. Which are the applications that can use this authorization server to get tokens from it. To do that, we will have to extend a class called the authorization server configurer adapter. The authorization configurer adapter, the authorization server configurer adapter, you see this name, probably it already sounds familiar to you because it's very similar to what we've used now as being called the web service configurer adapter, and we will still use that the web security configurer adapter, and we will still use that class, but this class is named very similar because it's pretty much the same thing, but it's for configuring the authorization server. So in our case, what we'll do is something very similar to what we were used to do when configuring a simple Spring Security application, and that's overriding some configure methods. And I will have to override actually two configure methods here for the beginning. So let's override the configure methods. Out of three, we need for the moment to discuss only about the clients and the endpoints. At some point, I will also discuss about the third one, but you will see the third one is basically related to the access to the endpoints exposed by the authorization server, and we will need that only later when we discuss about the communication between the resource server and the authorization server. So for the moment, for us, only these configure methods are essential. One of them receives as a parameter this client configurer. Of course, as the name suggests, the client configurer allows us to configure the clients for the authorization server. So to configure some credentials representing the applications able to use the functionality of this authorization server. The second one, you will see I will use the second one actually to attach the authentication manager that I have for the user management I have just developed in the previous configuration class, to couple it, to plug it into my authorization server configuration, because this authorization server configuration, what I expect it to do is to use precisely this user management I have done here. So the link between them is the authentication manager. So what I will do actually, I will take the authentication manager and I will plug it into my authorization server functionality, and to do that I will use this endpoints configurer I receive as a parameter for the second configure method. So this is basically why I needed to override these two configure methods. First things first, let's configure the clients. So I will say clients, and then you will see we have different solutions to configure the clients. Of course, I will start with the most particular of the examples, with the simplest one. But you will see that we can actually, we are offered the possibility to directly do that through a JDBC, and that's very similar to how the user details manager, if you remember, had a JDBC user details manager, where Spring Security provides something very similar for us for the clients. We have an in-memory implementation, which is called in-memory client details service, and that's very similar to the in-memory user details manager we have used for the users. So very similar the way we were using the user details service / user details manager to manage our users. Spring Security gives us now some contracts to manage very similarly the clients, because it's basically more or less the same thing. The way we authenticate users, now we know we need to authenticate another kind of entity. We need also to authenticate the client, so it's pretty similar. So this is why here you see that we have all these nice opportunities. For example, I could have even create my own client details service, and you will see you have this possibility. If I would like to implement my custom way of retrieving the credentials for the clients. Say I want to do what I was doing with the users in lesson 3, where I have created my own implementation of JPA User Details Manager, then I can do the same thing here using the client details service. The client details service is the contract which I can implement to specify Spring Security how to grab the client details. I won't get from the beginning into all of these details because it would be too foggy. You will see we still have to discuss plenty of things. So from the beginning, let's just start with an in-memory implementation like we have done here with the users. I will store both of the users and the clients in memory. And yes, I know this is not a real world case because in the real world you'll basically store them at least in a database, but it's the easiest way that you can use for the beginning to actually implement your own authorization server head to tail. So in memory, and then I will specify basically what I need to do. I will simply say I need to create a client and I have to provide the client ID, and then it's not called a password but it's called a secret, which is basically the same thing. So we need a secret for this client, and then we also need a scope for this client, which the scope is something very similar to the, if you want to the authority or to the role for the user. We can define a specific scope and then use the scope in the authorization rules for the client. But for the moment, again, this is something we can simply call it read, and we don't care what it is. We will discuss about it later when we finish with the basics. But we need more than this in almost all the situations. And in the one we'll start with, we actually need at least one more thing. And now I'm going back to my diagram, and remember my first questions when I have presented you this diagram, which were actually my first questions that I said we still need to clarify. Well, they were, how do the clients actually get the tokens? How can a client, which is the way precisely in which the client gets a token? Does the client get the token directly from the server by providing the user credentials? Should the client ask the user enter the credentials directly somewhere in an interface of the authorization server? Does the client need the credentials all the time for the user? And all of these questions, actually they have each of them one answer, but for all of them the answer relies to what we call a grant type. A grant type, or what we call the grant type in OAuth 2 terminology, is the flow, the precise way in which the client obtains the token. And OAuth 2 defines more grant types. We will discuss about 4 of them. There are more, but some of them not supported by Spring Security and one of them deprecated, so not essential for you. So basically the grant types, so the ways in which the client obtains the token we'll discuss, are the authorization code, the password grant type, the client credentials, the refresh token, and then I will tell you there is an implicit grant type that it is supported by by Spring Security. We'll discuss it briefly, but will not implement it because it's deprecated. So these grant types, this is how the token gets the how the client gets the token. So let's summarize them here. So we have the authorization code, and we have the password. Its password is basically considered, I will say, almost deprecated, but I have seen it used so many times yet in projects that I would like actually to discuss it with you, and moreover is the simplest one, so we can start with it so that you understand it easier. So generally the recommendation is try not to use that, avoid using it in your applications, but it's a great way to actually understand better the grant types. and I've still seen it in plenty of already existing systems, so I do recommend you know about it, so I will discuss it. But then we have the client credentials, is called, and then we have refresh token grant type, and we have the implicit, and this one really is deprecated, so it's fully deprecated. That's called deprecated. This one we won't discuss. Is actually authorization code is somehow the implicit grant type number 2, is the enhanced implicit grant type. So what we'll discuss in the authorization code is the implicit grant type with one more step. And then you will see that even an enhanced authorization code that's called with the proof key. So it's called the PKC, so the proof key authorization code. Again, we'll refer to it later. I'll tell you, the OAuth 2 systems and the OAuth 2 chapter is a quite complex one. We'll discuss a lot on it. But I will try to give you all the needed details. I will try to give you all the details you'll need to create secure and to have no problems when you would need to implement such a system with Spring Security. So follow me up to the end and you will know everything you need to know about all of this. I know it's complex, I know it's a lot of things to know, but you will still learn them as you have to do them, to use it properly, and everything you actually need to know. So again, being that it's actually, even if it's not actually recommended to use it further, I will start with the password because it's the easiest one, and I will add one more method to my client here, and I will say that my grant types, and I will only add the password here. So only the password. And for the moment, that basically is everything we need to have a client. So we have a client, we have a user, and the only thing we haven't done is link our users to the authorization server. If we do that also, then we actually can consider we have a usable authorization server, and we can test it from a postman. And you will see then how the first grant type works, and we discuss each of the grant types one by one, so that you understand how to configure them and how these things work. How do we link the users to the authorization server configuration? Where basically the simplest way to do that is extending here the web security configurer adapter, and then you know that the web security configurer adapter has the authorization manager bin method that you can call to get the authorization manager. What I want to do is get the authorization manager and put it into the Spring context. So if I override the method that returns the authorization manager bin and add an @bin above it, then I'm sure everybody agrees with me that this instance returned now will actually become a bin in the Spring context. And being that now I have the authentication manager as a bin in the Spring context, I can just go further and inject it here, and then configure it to my authorization server using the configure method that receives the endpoints as parameters. So endpoints, authentication manager, and I configure it, I have set it, and I, for the moment, don't need to throw any exception. By the way, this way of taking the authentication manager is the same one I've taught you to do when discussing about using multiple authentication providers in one of the previous lessons of the same stream. You remember we've done actually the same thing. We have added it to the context, and then we were able to inject the authentication manager in the filters to create some custom authentication. So we basically reuse something that we have learned previously in the same stream. If and only if I didn't forget anything, and hopefully I didn't, now we have a fully functional authorization server. So let's try to start it and let's try to use it. So I've just pressed the run button. I will wait a couple of seconds for my authorization server to start. And then I will try to use it by going to Postman and trying to obtain a token, because what we've discussed is that OAuth 2 is all about obtaining a token. And perfect, we have started our authorization server. Before going to Postman, I would like to show you something. In the console, you will actually see some endpoints that have been exposed automatically because of our configuration. One of them is called the token endpoint. And yes, you guessed, this is actually the token. This is actually the endpoint we will use to obtain a token. We have other two endpoints. One of them is called the token key. We'll discuss about the token key when we'll learn how to configure asymmetric keys for signing tokens, and you will see this token can be used easier when we do key rotations, but that's something you will learn in one of the next lessons. And we have this check token, which is also called the introspection token endpoint, which we'll again discuss when dealing with the resource server and the way the token is validated. Because remember my second question at the beginning of this lesson, when I have told you how does actually the resource server know that this token is a valid one. You will see there are multiple options actually to do that, and we will implement them one by one in the next lessons. And at that point, you will that's the point when we'll basically at some point discuss about the check token, so the introspection token endpoint. Good, but that being said, for the moment, the only thing we want to discuss is how to obtain a token. So let's discuss how to obtain a token. We only have a client, and the only grant type supported is the password, so we know we only have to use the password grant type because something else is not supported, and we only have an user, so we will need to use this user to get the token. What's actually the password grant type? The password grant type is the grant type where the user provides its credentials to the client, and the client uses the credentials of the user, presenting them to the authorization server to get back a token. So in my case, if I want to use the password grant type, it's called like this because actually the user provides all his credentials including the password, so user plus password to the client, and then the client sends the user plus password to the authorization server, and if they are correct, if they are recognized by the authorization server, then the client will get back a token and will be able to use this token to call the resource on the resource server. You can see now also why it is not actually recommended to use the password grant type. Well, you can do that if you really trust the client. So assuming the client is part of the same system with the authorization server, and it doesn't impose so strong security, for example, then you could actually use the password grant type because it's a little bit simpler than the others. But be very careful because it assumes that the user shares the password with somebody else. Instead of having only two parties, the users and the authorization server knowing the user's credentials, now you have three parties. The more parties you have knowing the credentials, the less secure your system is. So that's why basically again using the password grant type is not really the greatest choice, but sometimes you will still see it implemented and you will find out that simpler systems still use it because it's a simpler way to do the authentication. And again, it's a very simple way to understand how to get a token. It's the most direct way basically for the client to get a token on behalf of the user. So it simply gets the user credentials, sends the user credentials. If they are correct, it gets the token. If they are not correct, then it doesn't get the token. That's pretty easy. So let's do that. I'm going to my Postman here. I will start a new tab, and the token endpoint is actually a post endpoint, so I need to change the method here. And I do an HTTP localhost 8080, and then I have OAuth 2 token. That was basically the token endpoint you see here, /OAuth2/token. And then for the client to call the token, it needs to authenticate itself. And in my case, I guess it was client 1 and secret 1. So this is the username and password are the client and the secret of our client. And remember, we have set them here, is this one and this one, the client ID and the client secret. So I do basic authentication with the client ID and the client secret, and then through the parameters of the message I have to send the grant type. So I will tell the authorization server I want to use the password grant type, because there are more ways to do that. So I need to inform somehow the server which of the ways I want to take, and I tell the server, yes, I want to use the password grant type. And then because the password grant type relies on having the username and password, I need to share with the application. In this case, remember, Postman is, instead of my client, the username of the user and the password of the user. So this is also why you will never do that outside of HTTPS, because you don't want these credentials to be actually shared in clear text. And then I also need to give the scope. The scope is also needed to be provided. The scope of the client, the scope that is requested. We only have one and we don't care about it, but I have to add it in the request. And I do send now the request, and I get back a response. This is the response I get back. The access token and the value of a token. Well, this is my token. And then I have the token type bearer. Bearer is just a standard way, a word representing a standard, meaning that anybody having the value can use the resources for which the value was issued. So that's everything about bearer. Don't stress too much about what bearer is. Yeah, bearer is just the way the authorization server is telling the client, anybody having this token can use it to access the resources. Be very careful what you do with this token. If you lose it, then somebody can access the resources on your behalf. Of course, the token usually has an expiration. We'll discuss about the expiration when we get to discuss more in detail the tokens. And then you see the scope for that you have requested, which should be the same one you have requested when you did the request. Now let's discuss a bit more about this token value, because from all this for the moment we are the most interested on the value itself. If you have watched some other tutorials, read articles, read books about it, you might have seen in some situations that the token doesn't look like that. You have seen large value of the token, maybe looking strange, and that's because in general we use an implementation of the token that's called a JWT. And I will get to the JWT in one of the future lessons, but for the moment I will use plain tokens. That's all what you see here, also called opaque tokens. These are tokens that only acts like some passwords. They don't contain information. You don't see any information here. This is only a password for you. You can use this token like a password to call the endpoint, but you see nothing inside it. It doesn't give you any clue about the user, about the client, about its expiry time. It's just a normal string containing no information. Later, we'll discuss about other more complex implementation of tokens. JWT, JSON Web Token, is the abbreviation of the JSON Web Token, is one of these more complex implementations. And this implementation of token called JWT holds data and has a defined structure. But OAuth 2 as a standard, it doesn't force you use any kind of implementation of token. You can use any token you'd like to. And I will even teach you how to create your custom tokens if you'd like to. So you can create your own tokens that are not opaque and they are not JWT. They are your custom implementation. You can do that. And we'll discuss about the token store probably in the next lesson. And at that point, I will teach you how to create your own tokens that can be very, very, very specific to way you thought about them. But this is the easiest way to actually create a token, is to create a unique identifier. This is an UUID. So what you basically see here is just a value of a universal unique identifier, an UUID, that was generated and that I can use now to access the endpoints. We won't get now on how to use the token, because using the token, remember from our discussion, our diagram we started with, is the duty of the resource server. So we will get on how to use the token only when we'll discuss about the resource server in the next lessons. But you have learned for the moment how to use your first grant type, that's the password grant type, to get a token. Later you'll learn how to use this token. But you got the token, so you've done most of what's about OAuth 2 for the moment. OAuth 2 is about getting tokens for authentication, and that's basically what you've done. Let's go further and let's learn to use a second grant type. This is called the authorization code grant type, and you'll see it's a little bit more difficult than the password grant type. So it's still about getting a token, but you will have more steps. In the authorization code grant type, the user doesn't share anymore its credentials with the client. What actually happens is that when the user wants to use some functionality of the client for which the client needs to call the resource server, the client basically redirects the user to the authorization server. So it sends the user to a page displayed by the authorization server where the user can directly authenticate. So instead of having the user sharing the password with the client and then sharing it further with the server, the user, in case of the authorization code, directly inserts its credentials in a page exposed by the authorization server. So this is why the authorization code grant type is more secure than the password grant type, because in the case of the authorization code, you don't have the client anymore knowing the credentials of the user. Only the user and the authorization server know which are the credentials of the user. So in this case, when the user correctly authenticates, the authorization server provides a token back to the client by doing a redirect call. So the steps are: user calls the client to see some functionality, client observes it needs a token to get the user details, so it redirects the user to the authorization server. The user authenticates with their username and password, and the client receives the token from the authorization server. Well, that's relatively true. What I've told you here is basically the description of the implicit grant type, which is this one here. So I have a question. So I see the grant type can divide into two types. No, actually the grant types can divide into 1, 2, 3, 4, 5, and I think there are a couple more grant types out there which are not supported by the Spring Security. So it's not two of them, it's actually more of them that I will have to present you. It's all of this I have enumerated here. So I started with the password, and now I was discussing the authorization code grant type. And what you have seen here is basically almost the authorization code, almost, because what I have described you here is actually the implicit grant type. In the case of the authorization code grant type, instead of directly getting the token after the user authenticates, I get a so-called authorization code, and the client does one more step to get the token. But because just speaking about it is complicated and it won't allow you see the difference, my suggestion is let's try to use it first. Let's use it and then you will see it further. And because we don't have a lot of time, we will complete today the authorization code grant type, but we will retake it starting with the next lesson, because I really want to make sure that you understand very well which are the flows used by the server. So let's see. how the authorization code can be used. Where of course, like in the case of my client 1 having a password grant type, I can have a second client without the memory here, sorry. And I can have a second client, and this second client will basically use the authorization code grant type. And I of course need to have different credentials, at least different client ID. The password is irrelevant, but client ID needs to be different. And when you do use the authorization code grant type, you also need to have a redirect URI. The redirect URI is needed because it's the way the authorization server will call back the client. If you don't have this redirect URI, the authorization server wouldn't know how to call back the client. Because the steps were user is redirected, it authenticates, and then the authorization server redirects the user back, the code back to the client. But how can the server know? How can the server call the client? How can the server actually call back the client? Well, through this redirect URI that we are using. So that's why here we also need to specify the redirect URIs. And in my case, I don't have a client, so I simply can just use something that doesn't exist. You will see an error in the browser. We will know why this is. But this would basically be an URI of the client where the code should be given. That should be called by the server to give the client the access token. But fortunately, we finished with the configuration of the client. But you see what's missing? In my case, did I actually implement any way in which my authorization server can actually interact with the user? Nope. So this is why I've started with the password grant type, even if it's not recommended and not with the authorization code. The authorization code is a little bit more complicated. The authorization server also needs a way to provide the user, it also needs to provide the user a way to authenticate. So it needs to provide an interface, such some login form, something where the user can insert their credentials so that it gets authenticated. Fortunately, Spring Security has a form login implementation that comes out of the box. So in order to do that with your application, I would just have to go here, and as you've learned in one of the previous lessons, override the configure method. And then you can select the form login authentication method, and this way your authorization server will automatically benefit of a form login. And then of course I will actually also have at least to specify that all the requests are authenticated like this. But only by doing this configuration I have a login form, so I should be able to prove how the authorization code works. No worries, I know it's the end of the lesson and I won't be able to describe everything, but I will again start with the authorization code grant type at the beginning of the next lesson, so you will learn all the details and you will have all the chances to learn everything. Yes, if you refer to the redirect, we have two grant types that have a redirect. The implicit one, which is the deprecated one, the old one, and we have the authorization code, and we actually have a third one, the authorization code with PKCE. We will discuss it in the next lessons. All of them use redirects. Cool. So let's restart and let's try to use the authorization code. Let's see if we are actually able with what we have now to actually work and get an access token. Can we actually have an access token by what we've implemented with only this very simple configuration? Well, fortunately the answer is yes. So you will, in this case, have to, I can't show you anymore how this works in Postman or only in Postman, because I need to log in a browser, because all about authorization code is this fact that we are redirected and we have to log in a form. So I can't simply prove it from the Postman. I need a browser for me to be redirected so that I can log in directly to the authorization server. So that's now why I'm accessing it through the browser. My localhost 8080 OAuth to authorize is the standard endpoint that we call in this case. And then we have to specify which kind of response we'd like. And this is where the split comes actually. Code means I'm using authorization code. If I would have liked to directly be provided the access token, I would have written here implicit. So this is where I make the difference between using authorization code or using implicit. Well, I'm using authorization code. Then I provide the client ID. If I remember correctly, it was client 2 in my case, and the scope is read. I access this and I will be automatically redirected to login. Remember the steps from the diagram. When the user accesses the functionality, it's what I've done, but instead of letting the client call the authorized endpoint, I did that myself. I redirected so that I can insert my credentials, user and pass, directly in a form provided by the authorization server. Then the authorization server will provide back to the client an authorization code. So I'm going back, I'm writing the credentials. It was John 12345, it's my only user. I do sign in. I'm asked if I approve or I deny. That's the way it works. I say that I approve the call, and then the reason for why you see an error in the browser is, remember, we've used an inexistent redirect URI, but it's enough for us to see that we were provided the authorization code. You know now that, of course, if this URI did exist, then of course this was the URI of the client, and the client would have taken that code and would have obtained an access token. In our case, we will take the code and we will obtain the access token ourselves in Postman. We go in Postman, and if I want to use the authorization code, then I'm actually going here and specifying that what I want to do is use authorization code. I don't need any username and password anymore, of course, because it's not a password grant type anymore. When it's not a password grant type, you don't share the username and password with the client, so the client doesn't have them. I still need to add a scope, and I need to actually add the code. And then of course I need to use the second client, because the first client, well, I didn't configure for the first client the authorization code grant type, so the first client wouldn't be able to actually use. Only the second client has this grant type set by me. So that's why I'm careful, and I will log in with client 2, which is the client I can use to use this code. And I do send the request, and you will see basically the same thing you have seen with the password grant type. You will see the same response in which I have the access token, the token type expires in the scope, and of course by default my token is an opaque one, and again details about the token will come in one of the future lessons. But you will see, you have seen that following a different flow, which we call again in the OAuth 2, we call it a grant type, we were able to obtain again a token. If I press the send button again, I will get an error, because this code can't be used multiple times. I've used it once, I got my access token, then if I want to have another access token, I will have to re-authenticate. Or, as you will learn in one of the next lessons, use a refresh token. Good, I will stop now because we already spent the time for today, and I don't want to get you bored already. An hour, I think, is and a lot of knowledge I've shared is enough. So you've learned today what the actors in OAuth 2 systems are and what's their responsibility. And you've learned that we have multiple ways to get a token. Actually, you've learned that OAuth 2 is all about getting a token from an authorization server that you can use later to call the resources. You found that there are multiple ways, multiple flows to get a token. These ways are called the grant types. So we have implicit, authorization code, password, client credentials, and refresh token. And we have even managed to write our own authorization server with Spring Security, but we have only proved how the password grant type works and how the authorization code grant type works. We will start next lesson with the authorization code again, and I will create a better diagram for you to understand how the authorization code works. And then we will continue with the next grant types, and of course, following the next lessons, we will get to all the other responsibilities of the server. So I have some questions. Let's see which the questions are. First of all, sorry about my asking this question. You don't have to be sorry, that's why I'm here. Do you have solution to modify current Spring Security to support users in multiple organizations with different roles? Multiple organizations, I'm not precisely sure what that is, but for me it sounds like you want to have a Keycloak or something that allows you, a tool like Keycloak or Okta or Cognito or something that allows you to easier integrate with multiple other systems. This is how what your questions tells me now. So we will discuss about Keycloak in one of the next lessons. But maybe you can check out if something like Keycloak is a solution for you until that time, because I'm not sure if I can actually what I can actually tell you now more than this. But check out if you actually what actually you need to use is a solution like Keycloak. Again, we will do some examples with Keycloak in one of the next lessons, but that's not something of 5 minutes. Maybe that helps you for the moment. If not, yeah, we'll see further. Maybe you come back to me and we discuss about it, and we see what your situation is. I'm not sure. Another question is, do you have any update of the Spring OAuth 2 rewrite? Yes, of course I have. I've just told you at the beginning, a new authorization server starts to be built. On this channel, you will see that on the community section I have shared you the URL to the repository where the community starts to build a new authorization server. However, the authorization server will take, my opinion, not less than a year to become mature, and probably until then we will use what we have. So that's basically what I know about the status. Regarding a more detailed status, only what you have seen yourselves probably if you have followed that link is that some issues are created, some epics are created, and some people already started working on it. Hopefully we'll get more organized soon, and we will have a complete solution of a new authorization server as soon as possible. That's what I'm looking forward for. I hope you are also looking forward for the same thing. Enable authorization server is not deprecated until you will have a new solution. So remember what I've told you at the beginning of this lesson. We have this solution for the moment and no other solution than using a third party like Keycloak or Okta. This is the only way we can use an authorization server for. So no, enable authorization server for the moment. You can consider it deprecated, but for the only reason that some guys said it's deprecated because they will not develop on it anymore, it doesn't mean it's legacy, because you don't have any other options now. So what happens if you will look on the community, the tab of this same channel, Robert, you will see that the authorization server starts to be rebuilt. However, rebuilding an authorization server is not 1 month thing. The authorization server will take at least a year probably to get mature. Until then, you will use enable authorization server and you will use the authorization server solution that we have. So that's basically, one person has multiple roles per organization. Yes, but that's not a problem, David. What is why should it be a problem? You can even have multiple roles in Spring Security like this. So for example, here instead of having, you can have multiple authorities, yeah, whatever you want, or you can even have roles. So you can have multiple authorities or roles per organization. I'm not sure precisely if I understand your question, but I'm pretty sure that you can implement it even with Spring Security, but it's probably Keycloak or a third-party solution will help you for sure to easier implement that rather than implement it yourself. So check out first Keycloak and see if it works for you, and then maybe we discuss about in detail what you need, because yeah, I'm not sure precisely if I understand your use case, your specific use case. But yes, you can have multiple roles. Even with Spring Security, you can have multiple roles and authorities. Okay, super. Thank you very much for all questions. This was the first lesson of OAuth 2. We'll continue with the authorization server in the next lesson, and then with the resource server. And the next lessons expect to be only about OAuth 2. And again, I will teach you everything you need to know. For the moment, with what we have, when a new authorization server will be there, we will discuss, of course, about the new authorization server. And we'll also discuss about Keycloak again, but in one of the next lessons. Okay, thank you very much for watching. Thank you very much for your time, and have a great time for study until the next lesson.